So now that we know how to bypass blacklists with SSRF vulnerabilities, let's talk about a more difficult or a more challenging way to bypass, which is if the target website uses whitelists. So right here we have a website that looks very similar to the websites that we played with. Again, you click on a product, check stock, it gives you the amount of units. So again, we turn on our proxy, we check the stock, we send this to the repeater so we can play with it. And we have the request in here. So we're going to delete all that and let's send it to HTTP localhost. And you'll notice that this doesn't work. So it's actually giving us an error. And again, the error is very informative. This is not going to happen in real life scenarios, but you can see that it's actually telling us that the request has to go to stock.welikeshop.net. Assuming this is a black box testing where you don't know what's happening in the web server, we still don't know whether a blacklist or a whitelist is being used, but we know that when we typed localhost in here, our request is being refused for whatever reason it is. So the first thing I would assume is that a blacklist is used, and I'd come in here and do what I did earlier. So I'd capitalize some letters, send it again, and I'll notice it still doesn't work. So then I'm going to try the 127001 and all of the options that we spoke about earlier. And you'll notice that none of that is going to work. And therefore, I'll arrive at the conclusion that the target could be using a whitelist. So what do we mean by a whitelist? In a blacklist, we have a list of words that the request should not contain. And if the request contains any of these words, we block it. The whitelist does the opposite. We have a list of words that can only be sent in the request. So it checks if the request is in the whitelist. So if it's being sent to shop.com, google.com, or api.com, for example, then we let it go. Otherwise, we refuse it. So if we go back to our error message, you can see that it's saying that the requests must be made to stock.welikeshop.net. So basically, in the whitelist, they must have that domain in here, stock.welikeshop.net. And if your request does not contain that, then your request will be refused. Therefore, we need to somehow be able to send a request to this domain, but at the same time also have it to send a request somewhere else. So basically, we need to send a request that contains this domain in order to hopefully fool the server into thinking that we're trying to access this domain and then get it to do what we want and send the request somewhere else. So just to check, I just pasted the domain in here. Let's send it to see if it's going to go, and let's render the page. And it's better. We are still getting an internal server error, but we're not really getting an error as in it can't send that request. And that's probably because we're just sending the request as is in here. So what you could do, and I don't know if you came across this before or not, you can actually authenticate yourself when you're loading a URL. So you could authenticate by saying, for example, Zaid at this domain. And basically, when you do that, you're trying to log into the service using this username, using this syntax. So you can actually have an at in the URL. And if we send this, again, you'll notice that we're getting the internal server error, but it's still not complaining that we're trying to exit or get out of that page. Now, if you go ahead and read about how these URLs can be formatted, we have the standard in here. So again, you can look it up in Google and then go ahead and read it. It's very detailed and it's not easy to fully make sense of it at first, so you'll actually have to spend a bit of time to understand how this works, but it explains that user information may consist of a username followed by the @ So it's telling you that you could have a username before the URL, before the @ sign, and it also says optionally you can have a scheme specific information about how to gain authorization to access the resource. Now, if you scroll up, it explains how this scheme specific information. So you have the scheme in here. So it explains what a scheme is for you and how it should be formatted. And then in the authority section, it tells you that many URI schemes include hierarchical elements for naming authority. And the way this works is you have the double slash followed by a string, and terminated by a slash, a question mark, or a pound sign. So if you think of it, when you usually have URLs, you have HTTPS, and then forget about the colon, you have the double slash, and then you have something, and then we have forward slashes after that. So every time you have a forward slash, that is an authority, that is a scheme. So we can try to exploit this to our advantage, and hopefully the parser will understand that as a separate URL based on the information that we have in here. So basically what we're going to do here, instead of Zaid, I'm going to type localhost, and then this standard is telling me I can have a pound, a forward slash, or a question mark to format it in a way, or to tell the parser that this is a full URL. So after that, I can either have a forward slash, I can have a question mark, or I can have a pound sign. And now hopefully when the parser reads this, it'll read that as its own URL, and then whatever filtering, whitelist filtering, or if it's something else that is being implemented by the programmer, will not be triggered because we still have the stock.welikeshop.net in the URL. So let's send that and see if it's going to work. And as you can see, it's still complaining about this, but keep in mind that we introduced a new character in here, which is the hash. So let's go ahead and do what we learned how to do previously and URL encode this. So we're gonna URL encode it once, all characters, and then let's do it again. And let's send it. And perfect. As you can see, we can see the admin page appearing in here, because what we're doing right now is we're fooling the parser into thinking that this is an actual URL to send the request to, and we are able to bypass the filtering because we still have stock.weliketoshop.net, which is in the whitelist. So when this whitelist check is processed, it's checking if our request contains stock.welikeshop.com in the URL, and we do, therefore it's sending it to the server, and then when the server is receiving this, the parser is parsing this as a URL because we are exploiting the way that parsers should parse such URLs. So we're not really hacking anything in this, we're basically just learning how schemes work and how the compilers and parsers and computers process data and interpret them. So the main take-home lesson is to, first of all, see what do you have. So in this example, we have a URL, and see what has to stay. So we know that this part has to stay. We can't manipulate this. And then you're going to have to learn every single aspect and every single corner of what you are dealing with. In this example, we have a URL. So if you're really determined, you would go ahead and read the standard and learn how URLs are formatted. Where can you use pluses, minuses, and dots? Why do we sometimes have double slashes? Why do we have question marks? Why do we have pounds? How parsers parse these values, and how do they deal with them, and how do they format them? And then once you do that, you'll be able to format it, piece it all together, and hopefully manage to bypass and get what you want. At the start of this series, when I started with SSRF, I mentioned there was an SSRF in Google that was awarded 120,000 euros bounty. And the guy, there's an interview with the guy that discovered it, and he was explaining how he discovered it. So it took him months, first of all, to discover it. He didn't just sit down and get it done, it took him months. And every time he gets stuck on something, he would go and read documentation, and even sometimes he left it and just went and done other bounties and done normal work, and then he would learn something new. And then he's like, oh, I can use this in whatever progress I made with this vulnerability. And then he goes back to it and he does a bit of work, and then he gets stuck again. And then he goes and learns about, again, whatever standard or whatever language or whatever library that is being used. And then he discovers something and goes back to it. So it's not always like you're just hacking or you're just doing something and you know all the information. There's always times when you're doing this properly. There's always times where you pause and you go and learn a lot about whatever you're dealing with, and then you come back to it.